Okay, folks, let's look at this A-level pure mathematics differentiation question. Okay, so calculus question. Okay, taken from an A-level pure maths past paper. Okay, for the edXL example. Okay, question number one. Sorry, the curve C has equation y equals 3x to the 4 minus 8x cubed minus 3 AI. So find dy by dx. Okay, so rate of change of y with respect to x. Remember, the power comes out as a multiplier and the power reduces by 1. So it becomes 12x cubed. Okay, so the power comes down as a multiplier and then the power reduces by 1. Okay, so 3 times 4 makes 12, and then we knock 1 off the power, minus 8x cubed, so that will go to minus 24x squared. And then lastly, whenever we differentiate a constant, guys, that always goes to 0, because think of it as 3x to the power of 0, okay? Remember, x is just equal to 1, okay, so it doesn't actually change the answer, okay? So 0 times 3 makes 0, okay? So we got to put minus 0, okay, we don't have to put anything there. Okay, so the derivative of minus 3 or negative 3 goes to just 0. Okay, that's part I done. Part I, find the 2y by dx squared. So again, differentiate dy by dx. So 12 times 3, that'll be 36. Okay, knock 1 off the power, so that'll be x squared. And then differentiate, minus 24x squared. So minus 24 times 2 makes minus 48. Knock 1 off the power, so that'll be x to the power of 1. Okay, or just x. Okay, remember, in maths, x to the power of 1 is just equal to just 1x to the power of 1. Okay, remember that in maths. Okay, so whenever you just see x, it means 1 lot of x to the power of 1. Okay, part B, verify that C has a stationary point at x equals 2. So this is when we, set dy by dx equal to 0, or even better, we can sub in, okay, x is 2 into dy by dx, okay, and then obviously show that it's equal to 0. So you have 12 lots of, okay, 2 cubed, subtract 24 lots of 2 squared. Okay, so remember, to obviously apply big maths here. Okay, do your indices first, okay, or just bring it into your calculator. Okay, when we do that, okay, so 2 cubed is 8, times it by 12 makes 96. Okay, so 2 squared makes 4, times but minus 24, it makes minus 96. Okay, double check it again if you're unsure. 96 minus 96 makes 0, so therefore that we have a stationary point when x equals 2, because when x equals 2, the value of dy by dx is equal to 0, okay? Remember, stationary points or turning points is when the first derivative, okay, is equal to 0, okay? So you're solving that equation, okay? So obviously the second method is obviously solve that, okay? That also works, okay? But I thought, this one was a bit easy, okay? So just obviously sub in x equals 2 into dy by dx, okay? And verify and show that we get 0 when we sub in x equals 2 into dy by dx. Part C, determine the nature of the stationary point given the reason for your answer. So now we're going to sub in x equals 2 into the second derivative, okay, so dy by dx squared. So we're going to have 36 lots of 2 squared. Again, just obviously bring this into your Casio, okay, if you're unsure, minus 48 lots of 2. Okay, I like to do it in my head, just for good practice. So 36, so 2 squared makes 4, times by 36, that makes 144. 144 minus 48 times 2 makes minus 96. Okay, so subtract 96. Now we know the answer of that is going to be bigger than 0. So if it's bigger than 0, guys, then we have, a minimum point. Okay, so we have a minimum point. Okay, so this is, obviously learn for your exam. Okay, so when the second derivative is bigger than 0, okay, the value of it, then we have a minimum point. If it's less than 0, then we have a maximum point. If it's equal to 0, then we have a point of inflection. Okay, but that, guys, you're looking at the first few questions in total worth 7 marks in our exam. Okay, so every mark counts. Okay, remember, to obviously show your full workings in your exam, guys. But that is looking at a typical calculus differentiation question. Okay, a question that is almost certain to come up on this year's A-level maths exam. Okay, so revise differentiation, revise integration, revise obviously modelling. Okay, and all the other topics. Okay, thanks for watching. Okay. Okay, take care. All the best.